So this is an introduction to Rook polynomials. You learn what are Rook polynomials here and how to calculate the basic Rook polynomials. Consider a board that resembles part of a chessboard and let n be the number of squares present in the board. So what is n? The total number of squares in the board. Two pawns placed on a board having two or more squares are said to capture each other if they are in the same row or same column. So for k lying between 2 and n, let Rk denote the number of ways in which k pawns can be placed so that no two pawns capture each other. So basically, when are two pawns said to capture each other? When they are in the same row or same column. So this polynomial 1 plus nx plus r2x squared plus rnx raised to n is called a Rook polynomial, and if we denote the board by c, then rcx is 1 plus nx plus r2x squared plus rnx raised to n, where n greater than or equal to 2. So what is rcx? The Rook polynomial for the board C. What happens if n equal to 1? Then rcx is 1 plus x. Notice that n is nothing but r1 here. And we can also write rcx as 1 plus r1x plus r2x squared plus rnx raised to n, where r1 equal to n, that is the number of squares in the board. So you need to remember this formula for rcx. What is that? 1 plus r1x plus r2x squared up to rnx raised to n. Now consider here r1 equal to 4. There are 4 boards here, 4 spaces here, and number of ways in which two rooks can be placed so that no two of them capture each other is 2. That means either you can have 1 with 4 or 2 with 3. So R2 is 2. What is R2? Number of ways in which two rooks can be placed so that no two of them capture each other. And R3 and R4 are all 0. So what is RCX here? 1 plus 4x plus 2x squared. Why is it 4 here? Because there are 4 spaces. Now consider a board with 5 squares, n equal to 5 here. So there are 5 squares here. And possible position for two non-capturing rooks will be 1, 5, 2, 4, 2, 5 and 3, 4. So R2 is 4 here. So what are the possible positions? 1 with 5, 2 with 4, 2 with 5 and 3 with 4. Notice that they cannot be in the same row or same column. So for this board, the Rook polynomial is Rx equal to 1 plus 5x plus 4x squared. Now consider this board having 6 squares. So there are 6 squares here, and two non-capturing rooks can have the following positions. There you can have 1 with 3, 1 with 5, then 1 with 6, 2 with 3, 2 with 4, 2 with 6. 3 with 4 and 3 with 5. I repeat once more, you can have 1 with 5, 1 with 6. You cannot have 1 with 4 because it's in the same row. 2 with 5, 2 with 3, 2 with 6. You cannot have 2 with 5 because it's the same column. 3 with 4, 3 with 5. So we have total, and we cannot have 3 with 6. So there are totally 8 here. So the 3 non-capturing rooks can have the following positions. Now going to 3 rooks, you can have 1, 3, 4 and you can have 2, 3, 4 also. So R3 equal to 2. What is R3? 3 non-capturing rooks. So 3 rooks can have the following positions here. And totally your Rook polynomial will be 1 plus 6x plus 8x squared plus 2x cubed. So 6 is the total number of squares available, 8 is the number of positions for 2 at a time, and 2 is the number of positions for 3 at a time. Now consider a board having 7 squares. You have the 7 squares here, and what is n here? It is 7. So two non-capturing rooks can be for 2 at a time. 1, 4, 1, 5, 1, 7. Then start with 2, 2, 3, 2, 5 and 2, 6. And then start with 3, 3, 7. Then you have 4, 4, 5, 4, 6. So how many are there totally? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. And if you take 3 non-capturing rooks, so what will they be? You can have 1 with 4 and 5. So 1, 4, 5 and 1, 4, 5. Then n is in the same column, and 2, 3, 5. There are only 2 positions here, and the rest of 4 non-capturing rooks, 5 non-capturing rooks are all 0. So the rook polynomial here is RCX is 1 plus, there are 7 because n equal to 7 plus 10x squared for 2 non-capturing rooks plus 2x cubed for 3 non-capturing rooks. Now for an n by n board, we generalize and we say that RC n by n x will be 1 plus n squared x plus 2 factorial into nc2 the whole squared into x squared plus 3 factorial into nc3 the whole squared into x cubed plus n factorial into ncn the whole squared into x raised to n. We are just going to, not deriving this, we'll work out problems on this later. So what is the rook polynomial for an n by n board? 1 plus n squared x plus 2 factorial. So 2 factorial, 3 factorial, it goes on up to n factorial. This is nc1, that is n squared, nc2 squared, nc3 squared, ncn squared. Then you have x squared, x cubed up to x raised to n. So this is the rook polynomial for an n by n board. Thank you, and I hope this was interesting to you. We have just learned about what is a rook polynomial, how to calculate rook polynomials for basic cases, and generalized it for n by n cases. Thank you.